Error correcting code, ECC, versus non-ECC RAM. Think of error correcting code, or ECC memory, as the ultimate insurance policy for a computer's data. In a standard computer, RAM is incredibly fast, but it is not perfect. Every once in a while, due to heat, electrical interference, or even cosmic rays from space, a single bit of data inside your RAM can spontaneously flip from a 0 to a 1. In standard non-ECC RAM, the computer has no way of knowing this happened. This silent error can cause a weird software glitch, a blue screen of death, or, worst of all for a cybersecurity professional, it can subtly corrupt a database or a piece of encrypted code without you ever noticing. As you move into server administration and high-stakes cybersecurity work, understanding the difference between the trusting nature of consumer RAM and the vigilant nature of ECC RAM is vital. Non-ECC, the standard choice. Non-ECC RAM is what you will find in almost every desktop, laptop, and gaming rig. It is designed for speed and cost-effectiveness. How it works: it trusts that the electrical signals are always accurate. If the CPU asks for a piece of data, the RAM sends it. If that data was corrupted by a bit flip on the way, the RAM doesn't care. The trade-off: because it doesn't have to perform any complex mathematical checks, non-ECC RAM is slightly faster and significantly cheaper to manufacture. For delivering mail, browsing the web, or even running local AI models at home, non-ECC is usually perfectly fine because the occasional crash is a minor annoyance, not a catastrophe. ECC, the professional guard. ECC RAM is the standard for servers, financial systems, and high-end workstations. It is designed for uptime, the idea that a computer should run for months or years without ever needing a reboot. How it works: ECC RAM uses a specialized mathematical algorithm called a checksum. When data is written to the RAM, the ECC controller calculates a small piece of code based on that data. The magic of correction. If a single bit flips later on, the ECC RAM compares the data to that stored checksum. It realizes a mistake happened, and here is the incredible part: it uses math to instantly correct the flipped bit back to its original state. The system never crashes, and the data remains perfect. Reporting: if two bits flip at the same time, which is very rare, the ECC RAM can't fix it, but it can detect it. It will immediately send a signal to the motherboard to shut down the system to prevent the corrupted data from being written to your hard drive. How to identify them physically. As a technician, you can often tell if a stick of RAM is ECC just by looking at it. Standard non-ECC RAM modules usually have an even number of memory chips on the side, usually 8. ECC RAM modules have an odd number of chips, usually 9. That extra 9th chip is the workspace, where the ECC controller stores the checksum data and performs its mathematical calculations. The technician's compatibility warning. For your A+ exam and your home lab builds, remember these 3 strict rules of compatibility. Motherboard support. You cannot simply plug ECC RAM into any computer. The motherboard's chipset and the CPU must be specifically designed to support ECC. Most consumer motherboards, like those found in standard office PCs, will either refuse to boot with ECC RAM or will simply ignore the ECC features, running it as standard RAM. Mixing and matching. You should never mix ECC and non-ECC RAM on the same motherboard. Most systems will fail to post, refuse to turn on, if they detect both types of memory in the slots. The performance penalty. Because the RAM has to do extra math for every single piece of data it touches, ECC RAM is technically about 2% slower than non-ECC RAM. In the server world, we happily trade that 2% of speed for 100% stability. Which one for you? In your current home lab setup in NYC, you likely don't need ECC, but as you transition into your cybersecurity career and start managing government servers or corporate databases, ECC will become a mandatory requirement to ensure the integrity of the data you are sworn to protect.